Okie dokie. Moments. And now we're working in 3D. What is the difference between 3D and 2D? 1D. That's it. Nothing else. Usually when we work in 2D, we say moment is force times distance, and we study the direction, the sign, yada, yada, yada. But in this case, when we're working in 3D, remember the moment as a vector in 3D is going to be the arm cross multiplied by the force. And what is the arm? And this is very, 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 and one more time, very important. That arm is the distance from the point that you want to calculate the moment until the line of action of the force. The line of action of the force could be the point where the force is applied or any other point in the line of action of the force. Meaning, find the moment of the force F with respect to the point O. And I used to put here a double tip arrow to represent moment. It's going to be R. What R? The first R that we need to calculate is the R OB, because it's the moment with respect to the point O. So that means that we need, how much is this arm here? That arm. From the point that I need to calculate the moment to the line of action, in this case, the point of application is part of the line of action, right? What is this arm? Arm OB. OB is going to be 0, 0, 0, and in this case it's going to be 8, 0.25, 1.25. So it's going to be 8 in X, and we are here, right? 0.25 in J, and 1.25 in K. And once you have that, and you have the force in Cartesian, you can create the determinant of that thing. So you put here I, J, K, and do the cross product. First goes the R. You have no idea how many errors I have to see in the student's exam, because they put F cross R. It's R cross F. So first you put this one, 8, 0.25, and 1.25, 1.5, I'm sorry. Why did I say 1.25? 1.5, 1.5. And then you put the value of the force, 400, negative 100, negative 700. And you know how to do this by hand, right? You say I, that multiplies, and then you block these two. 0.25 times 700, negative 700, minus 1.5 times negative 100. So I that multiplies this times this, minus this times that, minus J. Now you block this one here, that multiplies 8 times negative 700, 8 times negative 700, minus 1.5 times 400, plus K, that multiplies this K now, 8 times negative 100, minus 0.25 times 400. And that will be the solution of that. Now, you can use also the calculator if your professor allows you to use it. I really don't practice too much with this thing, but let's say there's a function here called vector. You can see it there, right? Vector, the second function. And now you create the vectors U and V. So you first say the dimension for the vector U is 3, and now you put the values. I was practicing now to see. You see, you put 8.25, 1.5, and now you create that vector. You go back to vector again. Now you are going to edit another vector called V, dimension number 3, and then the values are going to be 400, negative 100, negative 700. So once you have the two vectors, you go back to vector again, and now you go to math and select cross product. I was having this problem. I don't know how to solve that, so I'm gonna do the old school off on. I'm sorry, this is not the way, but this is the fastest way for me. So I'm gonna do math here, cross product, you see there, and then you go and you put vector again, and you put the vector u, comma, and then you go to vector again, and then you put the vector v, close the parentheses, and hit enter. And these are gonna be the results. So the moment with respect to the force O, the force with respect to the point O will be negative 25I plus 6200J minus 900K. That would be the value of the moment. If you need to know the magnitude of the moment, if you need to, will be the square root of 25 squared plus 6200 squared plus 900 squared. That will be the value for moment and of the magnitude. And the problem is not asking you for the magnitude, but that will be the magnitude. And the value will be in what units? Pounds, foot, or pounds. And that will be the first part. Second part, similar, but now the problem asks with respect to the point A, and the point A is there. So I need this line of action now. From here to there. So I need the coordinates of this and the coordinates of that and subtract this minus that, or I can run the vector. And I explained you before what that means. If I want to go from A to B, and I have to go parallel to the axis for the position vector AB, first I have to come in this direction, which means positive 8 in I, and then I have to go in this direction, which means 0.25 in the y direction, J, and 0 in K. That would be that. No, I don't understand that. I want to do it using coordinates. Okay, use coordinates, no problem. What are the coordinates of the point A? 0, 0, 1.5. What are the coordinates of the point B? In X, 8. In Y, 0.25. And in Z, 1.5. And now you subtract B minus A. 8, you say what? B minus 8. 8 minus 0, 8. 0.25 minus 0, 0.25. 1.5 minus 1.5, 0. Whatever way is the easiest for you or you can handle. You do it. And this is the arm. Once you have the arm, you can calculate the moment of the force F with respect to the point A. And that will be again I, J, K. And then you put here the arm, but in this case the arm AB, from the point that you want to calculate the moment to the point in the line of action of the force, 8, 0.25, 0, and the value of the force, 400, negative 100, negative 700. And now you just solve that here, which is going to be easier in this problem because all the values are basically there. So I go to vectors, vector u, I'm going to edit the vector u, yes, dimension 3, yes, and I already had the values from before, so 8.25, but in this case it's 0, so I'm going to put here 0, 0, and that's that vector. Come again the vector, now the vector v should be the same one, off, on, vector, edit, b, v, third dimension, yes, 400, negative 100, negative 700, that's what it says there, 400, negative 100, negative 700, and now you just do the cross product again. And I know this thing is gonna destroy me if I say vectors. So what is gonna happen? I have to investigate that. When I say cross product now, it brings me back to this point. and I don't want that. So off, on. If you find a better way, feel free to tell me. That works for me anyway. So I'm gonna go vector again, vector, math, cross product, and then you say the cross product of, you say vector again, 1, which is the vector u, comma, and the vector again, and then you go vector b, which is 2, and hit enter, and that will be the result for that part. The moment of the force F with respect to the point A is going to be minus 175I plus 5600J minus 900K in pounds per foot. Magnitude, square root of this square plus this square plus this square. Now the last question is with respect to the point B. What is the value of the force, the moment of the force F with respect to the point B? Magnitude, moment of the force with respect to the point B. Look at that. The force is applied at the point, meaning the moment is going to be 0. And that will be it. Keep watching, guys. Keep learning, please. See you next video.